Crystallography is the study of crystals. A crystal can be described as a regular polyhedral form surrounded by smooth faces, which is assumed by a chemical compound caused by the action of its interatomic forces when transforming from the state of a liquid or gas to a solid state. Another interesting detail is that crystallography comes from the word crystallon from the Greek language, which means cold drop or frozen drop. Crystals adopt different geometric shapes depending on the organization of their atomic structure and the physical and chemical conditions under which they develop. Some of these shapes are cubic, tetragonal, orthorhombic, hexagonal, monoclinic, and triclinic. Even if crystals form from the same mineral, they can differ in their shapes due to their condition of growth. For example, Peruvian pyrite is one of the minerals which regularly shows different shapes on the same crystal. It usually has octahedral, dodecahedral, and cubic shape on a salt crystal. When a crystal has a surface passing through its center and divides it into two symmetrical parts that are mirror images, it is called plane of symmetry. In crystallography, four types of axes of symmetry are possible: hexagonal, tetragonal, trigonal, and binary. The majority of crystals have a center of symmetry, although they may not have either axes of symmetry or planes of symmetry. For instance, triclinic crystals typically only have a center of symmetry. The crystal face arrangement symmetry is basically an expression of the inside atomic structure. Here I wanted to show you how many different forms a crystal can have. Uh, Here there are only 15 isometric crystal forms, but there are also 32 forms that I'm not showing here. Wilhelm Conrad discovered X-rays in 1895, and he was rewarded in 1901 with a Nobel Prize in Physics. With the discovery of X-rays, it was possible to observe the structure of matter in a non-intrusive way. Scientists were capable to produce a three-dimensional picture of the crystal's atomic structure by measuring the intensity and directions of the scatter beams. Later, in 1914, Max von Laue was rewarded with a Nobel Prize in Physics for the discovery of X-rays interaction with crystals, causing diffraction in particular directions. This depending on the crystal's nature. Another important finding was that X-rays could be used to define the exact positions of atoms inside a crystal and untangle its three-dimensional structure. Uh, it was discovered by William Lawrence Bragg and William Henry Bragg. This discovery was called Bragg's law. Crystallography underpins the development of practically all new materials, from everyday products like computer memory cards to flat television screens, cars, and airplane components. Crystallographers not only study the structure of materials but can also use this knowledge to modify a structure to give it new properties or to make it behave differently.